Alright, welcome back to episode number 2 of Corona Labs. And today we're going to take a look at a double displacement lab. Okay, so last time we did a single displacement where we did that metal of aluminum and copper switching spots. Today we're going to do a double displacement. So what we're going to react to, we have calcium chloride, we're adding some sodium carbonate. So, and then we're going to predict the products. With double displacements, or these are ionic compounds, what's going to happen are two of the ions are going to switch places, or they're going to switch partners. Okay, if you remember, calcium's got that +2 charge, chloride has a -1 charge, sodium has a +1 charge, and carbonate has a 2- charge. So when we're predicting what's going to switch, I mean, what do we think? Do we think a positive charge is going to pair up with a positive charge? Or is it more likely that the positive charges are going to switch spots and pair up with the other negative charges? Okay, so we know that like charges don't attract to each other. So what we know is going to happen is the positives are going to switch places, or the cations are going to switch places. And so my products, I'm going to get calcium is going to pair up with carbonate. And then sodium is going to pair up with chloride. So there's my word formula, but let's go ahead and write it as chemicals, or as symbols. So calcium chloride, calcium's got that +2, chloride's got that -1, so I need 2 chlorides. So CaCl2 plus, sodium's a +1, but carbonate's a -2, so we got Na2CO3 to make sure those charges balance out. Goes to calcium carbonate, so we got a +2 and a -2, CaCO3. Plus sodium chloride, which is a +1 and a -1, NaCl. And then balance, and then that to balance the whole reaction. Don't worry about that, we'll talk about that later. Okay, so here's the reaction we're going to see today, a double displacement. We're going to start with calcium chloride, sodium carbonate, we're going to react them, and we're going to get calcium carbonate and sodium chloride. Alright, so as you're following along with the lab that's online, so here's what we've got today with the lab. So we've got some calcium chloride right here. Okay, so we take a look at what it looks like. So it's a white solid, all right, but if you look at it, it almost kind of looks like Dippin' Dots a little bit here, if you ever had some Dippin' Dots. So there's our calcium chloride that we're gonna have. And here is our sodium chloride, or carbonate. So it's a little bit finer, a little more powdery looking, like that. So if you're following along with the lab, it says that we want to measure out 2 grams of each and dissolve both in 50 milliliters of water. So let's go ahead and do that real quick. So I'm going to turn on the power to the scales. Okay, so with a little help with the power of the YouTube and the edit there, what we've got here is we've got 2 grams of both calcium chloride and sodium carbonate already measured out. And we've got our 50 milliliters of water for both. All right, so now what we're going to do is we're going to pour them in the beakers, and we're going to see what happens, see if these dissolve or if these are soluble or insoluble compounds. Okay, so we're going to go ahead and pour this in here and see if this dissolves a little bit. So we've got our 2 grams of sodium carbonate here. We've got our 50 milliliters of water, and let's see what happens as I pour that in, if anything happens, or if I'm just kind of wasting time here. But I imagine it should dissolve. So we're going to stir that here a little bit. And let that sit. I'm going to keep stirring that, and we'll come back and take another look at that and see if it does dissolve all the way or not. Okay, what we're seeing is, looks pretty cloudy right now, but I bet as we give it a little bit more time, stir it a little bit more, it's going to go ahead and dissolve. The other thing we're going to do is we're going to take our other 50 milliliters of water and our 2 grams of calcium chloride. We're going to pour that in there, and we'll see if the Dippin' Dots dissolve or if they just stay as a solid. So again, already we're seeing some of those dissolving, some of those particles going into solution here. Okay, so we're going to go ahead and stir those for a second, and we'll be back when these are both dissolved. Okay, here we are back after these have been stirred a little bit longer, and what we see is we have 2 solutions that were actually soluble. So here was our sodium carbonate, and here was our calcium chloride solution. And if you look in there, you can tell, hey, it's clear. It's not cloudy anymore. We don't see any more solid left at the bottom there. So those have gone ahead and dissolved. All right, so if we're following along with our lab, our next step is going to be to mix these two solutions together and see what happens. All right, so we are ready for the next step. We're going to mix these two solutions together. So we've got two clear solutions. All right, we know what's in them. Those compounds have been dissolved, and let's go ahead and see what happens as I pour one into the other here. Let's see if there's any kind of chemical reaction that occurs. All right. So let's zoom into that a little bit. Let's see what we think here. As you're looking at that, so that went from a clear substance to looks rather cloudy now. Okay, maybe I can show you down here at the bottom. We just kind of see some of it. If I get that to focus there. So we see some of the particles over here on this side kind of starting to keep moving and dissolving, or not dissolving, but mixing. All right. So I would say, taking a look at that, that looks to be a chemical reaction to me. We mixed two solids or clear solutions together, and we came out with something that is rather cloudy looking now. So if I kind of, if I mix that up, it feels like there's some powder in there. All right. So yes, I would say that is a chemical reaction. We had those two solutions. Now, the next step, if we're following along with our labs, is we're going to filter it. So I'll be back in a second, ready to filter this. So here we are, ready to filter our solution now. And some tricks that we know. First off, we know there's something that's solid in this beaker because it's so cloudy. Okay, this is not soluble, and as we're sitting here letting this go, what you're going to start to see is it's going to start to kind of settle down to the bottom a little bit. If we were to let that sit overnight, that would be the case. So, but there's a solid in there, something that's not soluble in water, so we're going to want to filter that out. And one of the best ways to do that is just with plain old filter paper. Now, the important thing is here that we want that solid, and we want to know how much that made. Okay, that's our product that we're looking for in this lab, is whatever this white solid is. So in order to filter and know how much we have, the first thing we want to do is know how much the filter paper weighs. Because as we filter it, it's going to get stuck on this filter paper, but when we're doing calculations, we don't want to know the mass of the filter paper. So if we measure it here, our filter paper is 1.04 grams. You can just write that on with a piece of, with a pencil. 1.40 grams, so you don't forget. So now the next process of this is we're going to filter. So we've got our Erlenmeyer flask set up here with a funnel. We're going to fold the filter paper, and then we're going to pour our solution through and see what happens. So when we're doing this, we want to fold the filter paper in half once. We want to fold it in half again, and then open back up, and there's our nice little funnel to go ahead and filter our solution. So we're going to pour this through, and we'll see what happens here. So you don't want to over pour the filter, but we'll just kind of let it sit there and filter for a second. So let me take the camera off here, and let's take a look at what's going on here. Maybe I'll take the camera off. I should loosen that up. Okay, so as we're filtering it, what we notice here, what we can kind of see is the solution that's coming through looks really, really clear. So again, here's our So here was our original solution, how cloudy it is, and you can start to see that layer of solid sitting out there at the bottom. And then here's the filtrate solution that's coming through our Erlenmeyer flask there. So if we go up and look at what's happening on the Erlenmeyer flask, up top here, it doesn't look like much, but we can start to, oh, you can't really quite see it, it's not picking it quite up, but you can start to see there's a little bit of solids, some white solid that's starting to filter out on the top of that filter paper. And that's why we're getting that clear solution on the bottom there. So if we compare the two again, cloudy has our precipitant in there, or a solid that was formed from those two solutions. Clear, all that precipitant is being filtered out. All right, so instead of sitting here and watching this for the whole time, luckily with the power of YouTube, we'll come back when this is all filtered. And here we are back after it's filtered. So if we look up here in the top, You can see definitely that there is a white solid that was not there before. And if we look down at the filtrate solution, we can see that it is clear. All right, so what we wanted is in this top of this filter paper. So what we're gonna do now is we're gonna weigh this. Okay, so I'm gonna put a weigh boat on. I'm gonna zero up my scale. 0, 0, I'm gonna go ahead and take this and let's see how much product we made. Okay, so if we remember that the filter paper had a weight of 1.04 grams. So if we look here, it's 6.47 grams. Now you might be thinking, oh, this filter paper is wet, Mr. Bass, and how could a wet filter paper doesn't water add weight? And I would say, well, yes, you're right. Luckily, we have a piece of dry filter paper with the same compound that I ran and I let dry overnight. So this is what it would look like if we let it dry. Okay, it's really fine, powdery, and then if I write it over here, it almost kind of looks like chalk a little bit. Okay, so if I put that on there, so this is the dried compound filter papers, and what we've got is a weight of 1. Is that right? Yep. So we've got a weight of 1.87, but again 1.04 grams of that is due to the actual weight of the filter paper. So we have a weight of 0.83 grams of solid. All right, so what we want to go back and think of is one of these two compounds. Okay, so if this is our chemical reaction, calcium chloride plus sodium carbonate goes to calcium carbonate and sodium chloride. All right, so one of these two things over here is the solid that was produced. So use some of your background knowledge. Maybe you might not know what CO3 is, but you might know what NaCl is. So think, okay, well, does that dissolve in water? Does that not dissolve in water? Did that substance look like NaCl? If you kind of know some of that stuff. So hopefully that was good enough for you guys to follow along. Go ahead and finish out the rest of those labs. There's a couple calculations and a couple post-lab questions. All right. Have a great day. Have a good weekend. Hope you guys enjoy some Thanksgiving Day turkey.